Good morning, I'm Eric Mesvet. I'm an assistant professor here at the Department of Engineering and Architecture, which is a new department here in concerning the Faculty of Engineering here at the University of Trieste. You can find more info about the teacher of this today's lesson. That is me on that web address. Okay, just a brief outline of today's lesson. We talk about internet and the web as a premise for the remaining part of the course. Then we'll talk about HTML and finally about CSS, but from a more wider point of view about styling and representing a web document. Note that in this class we try to have a quite theoretical point of view, so to be honest, I think you'll not be able to you'll not master fully the technical respects of HTML and CSS at the end of the lesson. Of course, there is a lot of resources available online, so you can follow that resources for technical details about the HTML and CSS. Okay, we'll have one or two breaks. Moreover, if you have any question, please raise your hand and make your question. Okay, let's start with the premise about what is internet, what is the internet, and what is the web. The internet is, in the simplest definition, just a network of computer networks that are connected through a pair of protocols that is called TCP/IP. In this image, it's just a graphical representation made by the Opti project of the internet. It's not a qualitative; it's just a qualitative representation. Don't expect that it represents fully the actual state of the internet. But you can understand that there are networks there is a network of networks. And the way these all the devices connected through these networks is through this pair of protocols. Actually, today's internet is not just about computers. You understand that it's about a lot of different devices that includes computer, televisions, informatic systems on cars, for example, of course, smartphones, iPhones, Android phones, and so on. So the definition has to be extended to include all kinds of devices that use this pair of protocols and are connected to this big network. Let's see a brief history of the internet. Internet was born in the late 60s by ARPA, which is an organization of the Department of Defense of the United States concerning advanced research projects, and this kind of project includes military research and similar things. The initial goal of the internet, which at the beginning was known as ARPANET, was to connect all the computer systems of this important institution that, again, I say, included universities, research centers, and military organizations. Later, the ARPANET became the Internet, which is a sort of acronym for internetworks, because, as I said before, Internet is just a network of networks. It's interesting to note that just in the 90s, the Internet became used widely by business, while before it was mainly a means for this kind of institution I mentioned before for communicate each other. It's also interesting to see one of the big problems of the scenario that has been taken by ARPANET at the beginning. Since the goal was to make able to communicate different devices, there was a limitation concerning the channels of communication between these devices. At the beginning, these channels was mainly the telephone lines, and as you can understand, a single channel, a single telephone line has to be shared by many devices, because, for example, there was a single telephone line between a given university and another given institution. And so the old way of using this channel, that is known as circuit switching, was not more suitable for the new scenario of making able many devices on the two sides to communicate. So the idea behind the new behind the solution is known as packet switching. In the circuit switching, the channel is used at a given point in the time by only two parts that are the two communication sides. In the packet switching way, the same channel can be used at the same time by many devices, because it's not the entire channel that is being used by the two sides, but just a packet that travels on the channel. And of course, many packets can travel on the channel in small pieces of time. What is a packet? A packet is just the payload, which is the name, the jargon name that represents the real content, the real data in the exchange of information, and other data. This other data usually includes the destination address, of course, because not always the destination address is just the other side of the channel, and other information that usually used to check if the payload is correct when it is read by the other side. This kind of information is also known as checksum. Okay, another interesting thing is about the initial speed of the internet. Today we are used to certain speeds or ability of transporting data from one side to another. At the beginning, these speeds were drastically different. Users of the ARPANET that were, again, I say, big institution of US government, so military research centers and universities, were able to communicate at 56 kilobits per second, which corresponds to 56,000 of bits that are zeros and ones for each second. It's a very low speed compared to today's speed that we normal people are able to achieve. But more interesting, the other users of the early internet could exploit a very, very low speed that was about 100 bit per second, and using very old devices, old compared to today, of course, called modem, and these devices were connected to the telephone. Okay, we just saw what the internet is, a brief definition and a brief history. Now let's see what the web is. The web, which is a short term for the World Wide Web, also known as WWW, is just a collection of interlinked hypertext documents that are accessed by using the internet. This definition is quite wide, and yet it's not fully representative of today's web. But for the purpose of this class, we can consider it as a good definition. What is an interlinked? What is an hypertext document? An hypertext document is a document which contains a bit more than just text, and this text can be linked, can be connected with other text, which usually is included in other documents. So you can see this collection just as a network of different documents where each document can be linked to other documents. So let's see the brief history of the Web 2. The Web has been invented by Tim Berners-Lee at the end of 80s, in the 1989, and it was invented in Europe, differently from the internet that was invented by US. The initial motivation for the web was just the need of sharing scientific information. This guy, Tim Berners-Lee, worked at CERN, where they study different fields of physics and not only. And of course, they had the need of sharing the results of their discoveries and access the knowledge of other scientists. So at the beginning, this was the beginning, the initial idea for the web. As you can see, the need of sharing information is easily achieved by a collection of textual documents that can link to other documents. Because I can talk about a discovery of mine, maybe citing discoveries of other scientists, and this is a simple way to share my results and let others to exploit them, also by knowing to which sources I'm referring to. And this is, of course, the core ability of linking documents one to each other. Okay, from a higher point of view, the goal was simply to share information, that is, making information available to others. In this process, in the process of making information available to others, we can see about 4 steps that are key steps. First, there is the need of writing down information. At the beginning, the information is just abstract. Someone needs to write down this information, and we can call this someone the producer of information. Note that write down is an informational term, because of course we can consider this producer that writing down with the pen on a sheet, but also of course writing down with a typewriter or computer and so on. Then there is the necessity to being able to locate the information. Once the information exists, one that one accesses the information should be able to locate this information. In the next part, in the next portion of the class, I'll often make a parallel between the web and a public library. In the public library, the information exists, but you have to locate the information. You cannot simply go there and expect that information comes to you. So you have to provide the public library staff with some kind of identification of the information you are looking for. The same is in the web, because there is the necessity of being able to locate the information. Then there also be the necessity of a way to ask and receive the information. You cannot invent every time the way you ask for the information. For example, you cannot invent the way you communicate the location of information and you ask for the information. And of course, the one who gives you the information should give you the information also in the same way, because everyone wants to access the information, and the information should be accessed by everyone, because the initial goal was to share information, should be able to access the information in the same way. And finally, there is the necessity of representing the information. Once the information exists, has been accessed, located and accessed, in some way the information should be represented. This is maybe the more difficult part to include in the parallel between the web and a public library, because in a public library the information is exists and is represented as in the same time, because we consider that the information is represented as books. In the web, as you can understand, the information exists in a form that is not material. It consists of data on computer systems, but at the end should be used by humans, and so the information has to be represented in some way. All these key points should be solved in a way that is commonly accepted by all parts. And this is the goal of the web, to provide this way, to provide these standards that are commonly accepted by each part. With each part I mean all producers and all consumers of information, of course all those parts that provide tools for sharing the information. How to provide a common way to respond to these four needs? By web standards. Web standards are sort of rules, rules that are commonly accepted and resolve the possible uncertainty in each of these steps. More in particular, there are four standards that concern these key points. From a more precise point of view, the standards are just three, because the first and the last standard, the first and the last key points are covered by the same standard. Okay, the first standard is HTML. HTML is a set of rules that say to the producer how to write down the information so that it can be managed by all the remaining parts of the process. The second key point is solved by URL, that is a standard that say how to define a location for a web document, or in other terms, a web resource. The third part is HTTP, which is a set of rules, so in other words, a protocol that say how to ask for information, information available in the web, so how to ask for web documents and how to provide these documents, and from another point of view, how to receive these documents. Finally, there is the part concerning the representation of web documents, the representation of the information. Also, this part is known by the HTML standard, a different part of the standard, which also concerns CSS that we'll see in the last part of today's lesson. Okay, all these standards are provided by standard organization that are organizations that manage the process of updating and disseminating the rules. the most important standard organization in concerning the web is, of course, the World Wide Web Consortium, W3C, of which you can see the URL on the slide. This organization provides the HTML specification, which is another name for the concept of standard. As I said before, the HTML concerns how to write down the documents, how to write down, in other words, structured information. That is information which is provided also with a kind of structure of the information itself. The same organization also provides the CSS standard, which actually is just a portion of the HTML standard. It's containing the same specification. And this standard says how to specify the desired representation of a given piece of information, of a given Word document. Another important organization concerning web standards is the Internet Engineering Task Force, IETF, which provides the standard for transferring through Word documents. That is the part concerning requesting and receiving, or from the other point of view, providing web documents. And this information is given by the HTTP standard, or the HTTP protocol. Also, the Internet Engineering Task Force provides the standard about location of resources of web documents. And the name of this standard is the Uniform Resource Identifier, of which the Uniform Resource Locator is just a subset, URL and URI. Okay, before going to speak about HTML more in detail, let's see some terminology about the parts involved in the web. The first important term is the web browser. What is a web browser? It's just a computer program which represents web documents. Just to be clear, a web document is a piece of information. Okay, just you know, the web is about sharing information. A piece of information is contained in a web document. So the web browser is that program that can ask for a web document for the user that is using this computer program, and represent, when he receives it, or represent using the media that the user has specified. Of course, you know, I think more than one web browsers. The most popular ones are 5. These statistics are not so updated. They are gathered on the last month of 2011, and says that the most popular browser, the most used browser, is Firefox, with about 40% of the market share. Then we have Chrome, just 3 points less, and then we have Internet Explorer. An interesting fact is that actually a large number of much of the information is accessed using mobile devices, Android devices or smartphone, and these devices use different browsers. For example, the iPhone, as you know, use a derivation of the Safari browser, while the Android, at least until the version 4 of the platform, use also a different browser. However, this is just to give you a big picture of which browser exists. On the other side of the communication, because you know the communication, I mean the exchange of information, someone who provides the information, someone that provides the information, and someone that consumes the information on behalf of the user. There is the web server. The web server is also a computer program that upon request provide web documents. What do I mean with upon request? I mean that the behavior of this program is passive with respect to the web browser, which is active, because the web server is always waiting for request for documents, and when he receives a request, he in some way that we see in the next slides finds the document that it was requested for and provide these documents in the response. As I said, we can exchange the term for the piece of information. We can use the term web document or web page. It's almost the same for the purpose of this course. Okay, what is the usual behavior of a web server? Let's consider a trivial scenario that is a scenario that today is not so common, but is interesting to understand the typical activity of this computer program. When a web server receives a request, from the other point of view, at the beginning there is a user that wants to access a piece of information. The user, of course, uses a web browser and specifies what piece of information he wants to access to by means of a URL. Again, recall that one of the key points is about specifying which is the location of the information that the user wants to access to. So in this case, the user, for example, specifies the URL of this web page. Then the browser that is on the user device contacts the web server asking for that document. We will not go so much in detail about how the web browser decides which web server to contact. Consider that it can be known by the first part of the URL that we see in the next slides, that is known as domain, and that allows the web browser to understand which is the physical address of the computer that on which the web server is running. The web server that hopefully contains the documents that the user asked for. The kind of request that the web browser makes on the behalf of the user to the web server is just a thing like, dear web server, give me the document named summer HTML that you should host. I think that you host, and this is the reason because I'm asking to you. In a more formal way, this kind of request is just as you can read there, that is a text string containing something like get/summer.html and another piece of characters concerning the nature of the request itself. Then the request arrives to the other part, to the web browser, to the web server, which looks for the document. In this trivial scenario, let's suppose that the document is there on the hard drive of the computer on which the web server is running. So the web server retrieves the documents from the disk and finally responds to the web browser and say, dear browser, here is the document, I found the document and here it is. Okay, note that we made the assumption that the document was indeed available for the web server. This is just a trivial scenario with a trivial description of the scenario. Of course, note that there is a lot of details that are missing. For example, okay, when the web browser communicates with the web server, how communicates, on which kind of channel, and so on. Consider that we are talking about the web. The web is on the internet, and the internet uses TCP/IP protocol. So it is the response. However, we will not talk about this issue again. Okay, let's return about the matter about how the web browser decides which web server to contact, and then how the web server decides which document to deliver to the in the response to the web browser. The key answer is in the URL protocol. That is a way to specify the location of a document, as I said before. Usually we can identify three portions in each URL. The first one is a kind of identification of the document itself. That is a kind of identification of the information, of the piece of information that the web browser wants to access to. In this case, the name of the document is just summer.html, and is the green part, that is the part that follows, in a first approximation, the further slash that you can see, reverse slash that you can see in this piece of text that is the URL. Then there is the name of the web server. The name of the web server is the portion that precedes the one I just talked about. And in this case it is www.units.it. This is the name of the web server. Okay, you can have the question about how a computer program given a name of another computer program, which is the web server that hopefully hosts the documents known as summer.html. How, I say, can decide the address to which forward the request. This is another topic. We are not talking about this topic, but the answer is in a protocol, in a thing that is known as DNS. However, at the end, the web browser is able to contact precisely the computer hosting the web server. So we have to give the problem as solved. Finally, there is in the URL there is an indication of the way in which to conduct the dialogue between the asking part and the responding part. In this case, between the web browser and the web server. This way is just a protocol, because we are talking about computer programs. So we should be quite precise about how to make things. And the protocol in this case is HTTP, which is not a surprise because I say that the web mostly works on HTTP. Okay, the one I talked to you about before was a trivial example. Let's see an example which is not so trivial, but also yet it's quite common. We see again with low details, but just to give you an idea of another example of a transaction between a web server and between a web browser and a web server. Let's suppose that the user is using the web to perform some shopping. So the user wants to buy a given good X from a given web shop S. Web shop is not a precise definition, just consider a e-commerce website. In some way the user indicates its browser that he wants to conduct this commercial transaction, and the browser built a request that is a bit more complex than the one we saw before, because in this case the user is not just asking about seeing a given piece of information, but it is also communicating something more precise about what he wants to do. In this case, he wants to buy something. He wants to buy this good we called X. So, of course, the request that the browser is making to the web server contains some kind of a reference to the object X, the good X. When the web server receives the request, let's say the web server on X, which is the web server that is in some way powering the web shop, then it's not just retrieving a web document from the disk, because we are talking about a commercial business transaction. So if I want to buy something, usually in a common shop, I say I want to buy X, and then the guy on the other side goes and takes this good, tells me which is the price, I have to give him the money, and so on. So this kind of situation has to be reproduced in this scenario too. So the web server has to run a procedure, let's say a program that manage the transaction. For example, the web server has to ask itself, is the required good available? Is it, in other words, is X in stock? Then which is the price of X, for example? Is there any offer for X now? Should I compute a different price for X for the user, and so on? At the end, the web server has to build a document, a web document, that is a piece of information that is a sort of summary of the outcome of the business transaction. As when you are in a common shop, at the end the guy says to you, here is the object, 10,000, too much, 10 euros, and this is the outcome of the transaction. I have the object, this is the price. There are also other transactions, because at that point you probably have to give him the money and so on. However, till this point, it's quite the same in the commercial part of our parallel. So finally, the web server produces a web document containing the outcome of the transaction, and delivers this document, this piece of information, to the web browser. So the last part of this scenario, the last step of this scenario is just as the one before. The server delivers a document delivers a response saying, dear browser, here is the document you require to me. Knowing that the request for that document also contained other information that made the server allowed the server to perform the business transaction. Okay, again, we can have some questions about this scenario. How are the requests and responses structured? How is a document structured? What is a document? Is a sequence of ones or zeros? Is a sequence of letters? Is a sequence of different wide kinds of characters? And finally, how to represent a document. Again, the answers to these questions are in web standards, and we are going to talk about, not all, but some of these web standards. Okay, so let's start to the first web standard, which is HTTP. We'll talk about HTTP just briefly, because the main topics of this lesson are HTML and CSS, but HTTP is quite fundamental for the web. And this standard concerns about how to build and consume web requests for web documents and responses for web documents. Okay, HTTP just an acronym for Hypertext Transfer Protocol, which itself says all about HTTP. It is a protocol to transferring hypertext documents. Transferring includes two steps, asking for and receiving, or from the other point of view, consuming the request and producing the responses. The other point of view, of course, is the browser, and the one point of view is the other point of view is the server, and the one point of view is the browser. Why we need a protocol? Because all the parts of the two sides of the communication should speak the same language. Okay, if any computer program can make a request for a given document in a different way, it's quite difficult to write a single computer program that is a web server that can respond to all these different requests. So we need to speak a single language, and this language is HTTP. The main facts about HTTP is that requests and responses are encoded as text. So when we are looking to a HTTP request or an HTTP response, we are just looking to a sequence of characters that we can inspect and that we can appreciate in some way. We can understand some details. Another key fact is that these messages, these requests and responses, travels on TCP, which is, let's say, the name, the kind of the channel that is at the time of the transaction that is connecting the web browser and the web server. So, in some way that we are ignoring, at some point, a tube, a channel exists between the web server and the web browser. This tube is made in a way that is known as TCP, and on this tube, these text messages are traveling in one way and in the other way. In one way requests and the other way responses. Okay, let's see a simple web browser. This is a web browser, web request, HTTP request that is coming from a web browser to which a user, I suppose, requested the page, the main page of the Wikipedia in the Italian version. Please note that there is no indication in the request of the almost no indication of the web server or the program who consumes the request. Of course, this program doesn't need to know its name because it's useless. Of course, in some way, the web browser found to whom send this request. So the request only contains the part of the URL of the location of the document that concern the document name itself. It doesn't contain the part concerning the web server address, because the web server address is not useful to the web server itself. Okay, we can see this request is just a sequence of text line. In each text line there is some kind of information. The most important for us is just the first line. The first line says, dear web server, get that is, give me this document, and this document is the following part, /wiki/pagina principale. Just note that also in the remaining part of the course that those small numbers that you can see on this left side, they are not part of the payload of what is shown on the slide. That one was the request, and let's see how it's made a response. A response is the text message which goes from the web browser, from the web server to the web browser. The response should contain at least two things according to what I showed you before. That is the initial the trivial and the not so trivial scenario. In each case, the response always contains an indication of whether the request is fulfilled and the content itself of the response. You can see highlighted in red on the first line the indication that says, okay, I found the document you asked me, you requested for. Then there is a number of complementary lines, and finally at the line 13 there is the first line, because the content is usually much larger than this small number of lines. There is the first line of the content itself. The content, what is the content? The content is the piece of information the user asked for. As you can see, the last line dots, that means the content is much longer. Okay, what kind of request exists? I showed you before that the keyword for requesting a given document is get. Get is not the only type of HTTP request. There are other types. One is POST. POST is for giving supplementary information, attaching supplementary information to the request. For example, in the scenario of the business transaction, the user wants to communicate that he wants to buy the X good, so he is making a request for a given document that corresponds to buying something, but is including the information of the X good. So in this case, probably he will use the POST type of request. There are also many other kinds of requests that we are not going to see. There are also different types of responses, because in the usual case, in the common case, the response is yes, okay, I found the document, but this is not the only type of response, because as you can understand, there could be cases in which the document is not available because, for example, I asked a document to the wrong web server, or I asked for a document that simply does not exist, and so on. Let's see just a couple of interesting kind of responses. The first one is the one we saw before, that is, okay, I found the document, and the content and the document itself is included in this response, is included at the end of the response. Then we have a kind of response that say, okay, this document exists, I, the web server, know that this document exists, but it's not here, it's available in a different location, and I'm giving you the location of where the document is supposed to exist. So in this case, usually the web browser will perform another request for the correct location. Then there is a response that concerns the case in which probably the user asked for the document to the wrong web server, or for a document that actually does not exist. This is the known 404 response code. That means not found. I don't find the document. It's not available here, or it could be available elsewhere, but I don't know. So I will not attach any payload, any document to the response. The response just contains this code and some other lines of supplementary information, but this is code saying, I don't have the response for you. I don't have the document for you. Finally, there is the internal server error response, whose numerical code is 500. This is a quite common response that covers in practice all the other cases in which something went wrong on the web server, or the web server program itself was not able to perform the requested action. For example, by X, I don't know if X is there, the program was bad, and so the response is just internal server error. And there are also other kinds of responses that we'll not see. Okay. I suppose it's a good point to make the first crack, and then we start with HTML. So we'll have 10 minutes until 11 crack. Yes, on the site teaching and I take summer school. The description of the HTML as a standard, as a set of rules, is dated 1991, and on this year the first draft of HTML specification was available. Then we had in the prehistory of HTML, we had a number of successive versions of the specification till the HTML 3.3.2 at the beginning of 1997. But we can consider this version of the specification of this version of the language as prehistory. Then we had what was the set of rules for several years till some year ago. The HTML4, probably the longest version of the longest in time, of course, version of the specification. We also had a variant of the syntax known as XHTML that is not interesting from our point of view. And finally, we have what is the HTML today, that is HTML5. The version of the specification that we are going to talk about is this one, is HTML5. There are significant differences between HTML5 and HTML4. In practice, we are not going to talk about these differences as differences, but we are. I show you some of these differences, but they are not important from our point of view. It's also interesting to note that the goal of the HTML language itself is likely shifted from these two versions, these two consecutive versions of the specification, from and in the final version, the language is specifically made for describing content and structure of the information. In the previous version, this division between content and structure on one side and representation on the other side was not so sharp. So this is a respect that concerns mainly the last version of the specification. Note also that in practice, this final version, the fifth version, is not yet ended, is not yet official, because the organization, the W3C that I told you before, works on the HTML standard, has not ended to decide all respects of the specification. In practice, the specification is ready to use, is ready since, let's say, at least 2-3 years, but officially is not given as concluded for the whole part. Okay, let's see a trivial HTML document, a very basic HTML document. Note the syntax. The syntax, you can see a kind of construct that is a piece of text included in the angular brackets. That is, for example, in line 2, there is a lower than character followed by HTML for textual characters and for letters, and greater than. These lower than and greater than are simply known as angular brackets. You can also see that there is a form of, for the moment we don't know the name officially, something included in angular bracket and the same thing included in angular bracket again later in the document, but with a reverse slash at the beginning of the textual part. We'll see the name in the next slides of this syntax, this kind of syntax. Another interesting thing is that you can see there is a form of shift of the position of the textual content in the document. This is also known as indentation. This allows the reader, the human reader, to infer the structure of the document visually just by looking at this indentation. For the moment, we do not know anything about the meaning of what is included among angular brackets. But of course, recall that in this document, what we expect to see is information and its structure. So we are not expecting nothing about representation. And in fact, okay, we can see some text, trivial text, probably not important vital information, but there is some information, and there is, now we cannot see because officially we don't know, there is some structure about this information. Okay, let's see the terminology about HTML. Everything that is composed of angular bracket, something, closed angular bracket, something, angular bracket, slash, something, closed angular bracket, is known as HTML element. The beginning part of this HTML element, the one included in angular brackets, is known as start tag, where tag is simply everything that is included between angular brackets. Then we have the content, the HTML element content, and then finally we have the end tag. This is just a terminology. Another respect of the syntax, of the HTML syntax, is the concern of the attributes. Every tag, every start tag may have attributes. Attributes are additional specification about the HTML, additional information about the HTML element. Each attribute is composed of an attribute name, that is just a sequence of letters, an equal, and an attribute value, that is the value for that attribute identified by the attribute name. In practice, this is all you know. You need to know about the HTML syntax. It's quite easy. Of course, there are some additional rules about HTML syntax. For example, some element types may not include, should not include any content. For example, there exists an element type known as IMG, that stands for image, that should not include any content. There is another element known as a BR, that stands for break, that should not include any content. In those cases, there is only the start tag, but the element itself is an element. I mean, there is only the start tag, there is no content, there is no end tag, but the element is an element. There are also some attributes that do not have any value. So, for example, you can see an attribute whose name is checked, and this attribute does not have any value. Finally, there exists a special syntax for including comment within the embedding comment within the web document. What is a comment? A comment is something that is should not be part of the main information nor of the structure of the main information of the document. A comment is a comment. So if a comment is something that is part of the information, it's not really a comment. So when the author of the document includes a comment in his document, should be aware that in the content of the document should not include anything that is important for the information consumer. Usually a comment is used, for example, in the design phase of the web document for the author for remembering, for example, why he made one design choice and not another. Okay, so let's start to see some important element type. The first one is the head element type that stands for header, and this part of the document, that is this element, the content of this element contains is about additional information of the document. What is additional information we'll see in the next slide. The other important part is the important part of the document is the body part, that is the body element, whose content is the information itself, information and structure itself. Within the head element, usually you'll find something like the title of the document, which is an additional information, and for example the author, information about the author, information about the copyright, information about description, brief description, usually quite a sort of abstract of the document, keywords and so on. There are also a lot of different things you can find in the head, but for the purpose of this lesson, just note that this is additional information. Okay, let's return to the document we saw before. I say that also if this is a trivial HTML document, also here you can tell apart what is structure and what is information. Also considering that it's not very important information. However, a first part of the structure is the part that allows the document consumer to tell apart which is the head from which is the header of the document from which is the body. This is an important differentiation because you can because of course the title is an important element. If this document included the author is an additional information and not the main content. There should be a way to distinguish between additional information and document itself. This way is the structure of the document, and in this case the structure is given by the head and body element. So for example, in this case the difference between structure and information is given by where the information is put. It's put inside the head element. Okay, in this case the structure says that is additional information, otherwise it is main information. Another part of the structure of the document it is the one you see as at line 7. There is an element whose name is P. At the moment we don't know what P is, but P is a piece of structure of information. Again, line 8, there is a piece of text followed by a element type. Again, this a element type, together with its attribute, its href attribute, is part of the structure of the document. Okay, so we can distinguish between information as content and information as structure of the content. If you recall what what a printed information is, what, for example, a book is. If you think at the book, there is, for example, there is a preface that is an initial consideration of the author. The fact that you find this initial consideration in a portion of the book which is preceded by a preface title is exactly structure of the information. If you find the same thing without the title preface, maybe at the beginning of the first section, of the first chapter of the book, it's a different book, because the structure is different, even if the content itself of the information, that is the text, is the same. So the structure of the information is important, okay? Also in the printed version of the information, if you think at the index or the title, if you find all together in a long line of text, is of course not the same as if you find that divided in different sections. And note that this difference is not given by the representation, it's given by the fact that that piece of text is the preface, not that is printed in another way. The piece of text is the preface. Okay, so you saw that there is a set of rules, the set of rules given by HTML specification itself, and we can, in general, we can distinguish at least among 4 kinds of rules. The first 4 layers, in other words, 4 layers of correctness. The first level concerns the syntax. Consider a web document. If a web document is written with the wrong syntax, it's simply a web document that is not correct from the syntax point of view. But there is also a set of rules that is actually not so clear to describe, and this set does not concern syntax itself, but concerns style of the HTML description of the document. For example, this set of rules include the fact that the author should divide information in more lines, possibly using indentation. Okay, if you write a HTML document on a single line of text, the document is syntactically correct, syntactically valid, but from the style point of view, the style of the document itself, not the style of the representation, is not so correct, because you should have used indentation and possibly, usually you do, using different lines for writing the HTML document itself. There is also a third layer of correctness that concerns the style of the representation. You can write a syntactically correct, syntactically valid web document, which is also written in a correct way from the style point of view of the HTML document, but you could include representation specification in a way that we are not talking about now, next portion of the lesson. Let's say that the color of the text is white and the background is white. Okay. In this case, the representation is obviously not correct, not valid, because the document itself is not cannot be consumed by anyone. Finally, there is of course a fourth level of correctness that concerns the nature of the information itself. From another point of view, this is a kind of semantic correctness. If you write a document which is valid, syntactically valid, valid from the style point of view, valid from the representation point of view, and you say that 1 + 1 is 3, this document is not correct. However, it could be correct from an exotic point of view, maybe on an artist or something similar. However, this is a fourth level of correctness. As you can see, the deeper you go, the lower you go on this correctness layers structure, and more difficult became to understand which are the rules. In this lesson we are talking about the first level, the correctness of syntax, because this set of rules is clearly specified in the HTML specification. We say something, just something about the remaining rules, but in practice this is a different and more difficult scenario to consider. Okay, let's talk about some basic syntax rules of HTML. First easy rule, easy to understand, is that elements should not be overlapped, but can be nested, as you probably saw in the example document. In the first line you see a valid piece of HTML code. There is a P element that contains a strong element. In other words, strong is nested within P. In the second line you see something that is not valid. There is a P element that begins with a start tag, then begins a strong element, then ends the P element, and finally ends the strong element. This is wrong. This is simply wrong. You can, if you read the specification, you will find this rule, maybe in a more verbose way, but this is a fundamental rule of HTML. Another rule concerns the way in which you can specify attribute values. The rule is quite simple again. The rule says that if the attribute value contains one or more spaces, the attribute value should be included in, should be quoted, so included in double or single quotes. First and second line are valid examples, because in the first line you see there is an attribute value without spaces and another with spaces, and they are both included in quotes. In the second line you see the first one without spaces without quotes, and the second one with spaces with quotes. This is okay. And finally you see the third line where there is the attribute value not quoted, and this is bad because it contains a space. From another point of view, interestingly, this could be a correct piece of HTML code if dog, the word dog, if dog is a good name for parameter, is a valid parameter attribute name, the document could be correct, but dog is not a valid parameter name, so this example is not valid. Another part of the simple HTML syntax rule set concerns the name character references, which says that there is a set of special characters, and each of these characters in this set has a name. The way to include these characters in the document is one way is using the name preceded by and character and followed by a semicolon character. For example, you can see DR, which stands for down arrow, that corresponds to the character which depicts a down arrow, or the character corresponding to the rational set in arithmetic. There is a lot of these kind of naming characters, and the rules say that you cannot include anything preceded by a and where this anything is a name for a name character. Probably this rule is not so impacting when you are authoring a web document, but it's an important rule. If, for example, you include in your document and dr without a semicolon, your document is syntactically not valid. Okay, the syntax rules are just these three that I showed to you. No, there is a large set of syntax rules. We are not going to talk about all the syntax rules that are not so interesting in this course, but how an author can cope with all these rules usually in two ways. The first one is that the author should know the specification, so should know all the set of rules, but it's not so easy. The second way is to use a validator, that is a computer program that knows all the rules and is able to understand when a document conforms to the rules. There is a fair amount of different validators available in the internet. One is the validator provided by the W3C organization itself. You give it the URL of your document, and the validator tells you if it is syntactically valid. Okay, let's return to the first way, the specification. What is this specification? I said before this term many times. The specification is the manual with the big M, in other words, the Bible of the web document author. It's a big document with big, I mean really big, which contains everything about HTML, everything about how to write a document. For example, it contains the list of all elements type. For each element it says when and where you should be use it. What I mean with when and where. Where is kind of this time element is can be nested within another kind of element. When is I author want to give a given structure to my information. Which element should I use? In terms of the specification also includes for each element type the attribute list, that is the list of all attributes that can be applied to the start type of the element. For each attribute it includes all the possible values, or in other terms all the way of specifying the values, and so on. So the specification is quite big, several pages. Let's see some pieces of the specification, just to appreciate the level of detail. For example, one thing that could bother you as authors is, I said before, some element should only contain the start tag, should only consist of the start tag. Which are these elements? The specification precisely responds to this question. I include here just a snippet of the response and a view on the full part of the specification. The specification says the start and end tags of certain normal elements can be omitted as described later, and then follow a big piece of text saying, for example, an HTML element start tag may be omitted if the first thing inside the HTML element is not a comment. Comment is, you can see, is a link. That means in another part of the specification they say exactly what a comment is. Or another case, an HTML element end tag may be omitted if the HTML element is not immediately followed by a comment, and so on. And there is a long list of cases. The specification is very, very detailed and says everything, because the specification is the source of knowledge about HTML. In other terms, who writes the specification, that is www consortium, decides what HTML is. So when they decide, they write down on the specification, and the specification is your Bible. Okay, another interesting example. In this case, we see the initial part of the description of the EM element. At the moment, we don't know what the EM element is. We can understand what the EM element is by looking at this part of the specification. Note there is a long, quite long list of details that clearly have a structure that we cannot appreciate, but this list is followed by a detailed textual description that say the M element represents straight emphasis of its content. Okay, so this part, just this part, says to you as author why and when to use the M element. If you have a textual piece of text in your information, and you think that some part of this piece of text stresses emphasis, so in that case you should use the EM element. You should include that part with emphasis within the content of the M element. Okay? And they also provide some examples. For example, this is a very interesting example. I won't read anything, but just to give you the important part of the summary of this example. There is a simple sentence, English sentence, that say, cats are cute animals. This is a plain sentence, no emphasis on anything. Emphasis, note that while I'm reading this thing, probably I'm giving some kind of emphasis. If I could emit elements while speaking, you could see E, EM, and so on, but I cannot, so you have to imagine that. In the second part, there is the same version of the text. The text is simply cats are cute animals with emphasis. In this case, the emphasis is on cats. So cats are cute animals. Giving emphasis to cats, probably, as they say, the statement implies that the kind of animal under discussion is in question. Okay, so probably I'm giving this information, and maybe I'm talking with a guy that likes dogs instead of cats, and I'm putting emphasis on the fact that I think that cats are cute animals. In putting the emphasis on cats, maybe I imply that I consider that dogs are not cute animals. Okay, so this piece of text with emphasis has a different meaning compared to the first version. Then there is a third version saying cats are cute animals. In this case, maybe I am debating with a guy saying that cats are not cute animals, and so on. Not two things. First thing, in practice, this element allow you to express the same kind of information you are able to express with voice. Okay. So it's maybe quite more easier to understand than to explain. However, the specification try to describe exactly the purpose of this element. Another interesting thing that is, from our point of view, more important is that in this piece of text, in this specification, there is no clues about representation. They are not saying EM should be written in a way rather than in another way. They are not saying EM corresponds to italic character or EM corresponds to bold character. They are just saying that the content of EM deserves emphasis. Okay? No representation, just information and structure. Where is the structure? The structure is in the presence or absence of emphasis. Okay, in this slide I just show you the validator. If you, parentheses, the slides are available on my website, and in the slides themselves there are a lot of links. So for example, here you can access the validator. This is the official validator of the W3C organization. You provide to the validator the address, the locator of the web document that you want to validate. You give him some other information, for example, which version you expect the validator to match the document, and the validator provides you with a validation, with the outcome of the validation of the document. And the outcome includes things like there is an element that should not be there, there is an attribute that is not valid, and so on. There is a problem with the syntax, and so on. Okay. I showed you before that there also exists a set of style rules, style in terms of HTML document. That is not the representation, just the long string of text, probably multi-line string of text that is the HTML document. Okay. This representation, the textual representation of the document, that is the long string, has should conform to some rules. The first one is please indent the HTML document, indent in a way that follows the structure, the nesting of the HTML elements. So if you have an element that includes another element, and the other element you decided to put in the following line, you should indent the line, the full line. The style rules are not so clear, so they are not described probably in the specification. Maybe there is some discussion about them, but they are not officially the topic of the specification. Another rule, for example, is concern the names of a given attribute that we are going to talk about in the last part of the course. So I think it's not easy to talk about style rules, so we are going to stop the discussion here. Just know that there exists a set of style rules, and you should conform as possible as you can, but it's not easy to understand which rules are. There are also the set of rules concerning the style of the representation. As I said before, one example is writing with a white color on a white background. This is a trivial case. Of course, we all agree about this rule probably. But talking about style of representation, of course we can also use the term design. It's not easy to reach an agreement of what these rules are about. For example, I could say that the comic font face is not beautiful. From the style point of view, is bad. But one of you could say me that the comic is good. So we cannot include the comic in the commonly accepted set of representation style rules. A subset of the representation style rules topic is given by the usability. Usability could be defined in a more precise way, but just to take it as is, just a matter of how a given web document can be easily consumed by the consumer of the document. You can find a lot of information about usability in internet. I just want you to say the beginning of a document, talking about usability. I'm not affiliated in any way with this author, but just to give you a clue that exists, that some literature about usability exists in the internet. This person is talking about 10 things that he call usability crimes, that are things that you should not do while authoring a web document. Let's just see one or two, just to understand what usability and what representation style rules are. For example, he says, if you produce a web document that includes a form, that includes a set of radio selectors, that is a set of choices among which you can only choose one, you should produce the document, write the document in a way that when the user clicks on the label of each radio option, the option becomes selected, and the others becomes unselected. For him, if you don't do it this way, it's a crime. It's just a point of view, but probably in this case I agree, also because it's not difficult to, it's quite easy to acquire this behavior. Another thing that this author includes in consider as an usability crime is producing a web document in which the logo, so the image that represents the website itself, is not clickable, and when clickable, that does not make the user go to the home page of the website. This is the kind of usability topics. There are a lot of them. It's not a thing that is commonly accepted. We cannot. It's just a matter of sensibility, let's say. Okay. Okay. Let's start about talking about more in detail about HTML elements. As I said before, there exists a way to specify comments within HTML elements. And this is including the comment itself between that structure of characters, that is open angular bracket, skeleton mark, line, and so on. That is the comment content itself. There is a way to specify the syntax of the document itself, and this is made just by including at the beginning of the document that string, doc type preceded by an exclamation mark. And then there is a long list of all other elements. We are not going to talk all the elements. Of course, you can find the full list in the specification or in a lot of other resources available online. One of those that probably deserves attention is the W3 Schools website, that is in some way affiliated with the WWW consortium, and in which you can find the documentation in a more easy, in a more friendly form. Let's talk about headings and paragraphs. How to specify headings, that is a form of titles and subtitles of specific section of your document. You can specify headings by the element H1, H2, and so on till H6. These elements are known as headings. And you can specify paragraphs by the element P. Okay, just to understand what are we talking about, you could ask me, is the font used in the H1 element larger than the font used in the H2 element, or is the vertical space between two paragraphs, between the content of two paragraphs, larger than the space after a breakline element? I hope you are not thinking about this question, because these questions are not good questions, because space, font, and so on are not matter of HTML. HTML again is just about content and structure, okay, not representation. Space and font are about representation. So a paragraph is not a piece of text that is represented with a given space before and a given space after. A paragraph is a unit of information that deserves a paragraph. So like in a book, a paragraph is probably a piece of the story that that is atomically contained and could be appreciated also without the preceding part or the succeeding part. Also, this way of seeing the paragraph is also the way you, as author, you should see while authoring a web document. Paragraph is an atomic piece of information within your web document. Again, an heading is a structural part of information, structural part of the content that say what follows is headed, is titled in this way, okay? An heading is not a part of text that will be rendered with a bolder font or a bigger font. This is another thing, representation. Okay, other elements, strong and EM. EM, as we saw before, should be used when its content has emphasis. What emphasis is specified by the specification. Emphasis itself is a concept that should exist also without HTML and related things. However, emphasis, the specification helps you by saying more about what emphasis is according to the specification, of course. Strong, you can use strong when you want to give a piece of the information importance. For example, when you are talking, when you are defining a concept, you could include the name of the concept itself as the content of the strong element. Another interesting element is code. Code is an element that contains a piece of code, usually a piece of computer code. Again, note that code is not an element whose content will be represented, for example, in a monospaced font or with a different spacing. Code is an element that includes, that is computer code. Okay? Code, in other words, specify the structure of the information. Okay, so let's talk about links. Links, of course, are important because, as we said at the beginning, the web is a set of a collection of interlinked documents. These documents that are each one linked to others. So there should be a way to specify that a given piece of a web document is linked to another document. That way is given by the element A, which stands for anchor. Anchor means the ending part of an abstract connection that links the two documents. Of course, when you specify that there exists a link of in your document, in a precise point of your document towards another document, you should also specify which is the other document, and you can achieve this need by using the href attribute, which stands for hypertext reference, whose value is the location of the other document. The location, that is the value of this attribute, can be specified in many ways. Just to mention the more important, the value can be specified as a relative URL, that is a locator that describes, that identifies a document that should be served by the same web server, so should be hosted in the same website, in other words. Another way is by using absolute URLs. That is a most common way that specify the full location of the other document. Another way is specifying a different portion of the same document, and this can be achieved using the syntax hash followed by what is an identifier of the other part of the document. And finally, there is also a way to specify that the content of the A element is linked to the email address of someone. Note that there exists a link element that instead has another meaning. A is anchor for a connection to another document. Link is another thing. We are not going to see what link is. Okay, there exists a way to specify lists. two versions of list. One is ordered and one unordered list. It's quite interesting to tell apart an ordered list from an unordered one, because they have a different meaning. It's not just a matter of what kind of ballet is used when representing. This is not a question regarding the use of one type of list instead of one other. The author should use an ordered list instead of ordered list, basing on what the list means. Okay, so again, content and structure, not representation. For example, if you are talking about a receipt, the list of ingredients is an unordered list, because you put the ingredients on the table and then you cook. There is not an order of the ingredients. The list of steps you have to do to perform while preparing your meal is an ordered list, because you cannot before put the pesto in the water and then boil the water and finally put the pasta. The right order is boil the water, put the pasta, and so on. So the real difference between ordered and unordered list concerns the meaning of the information. In this case, the meaning of the information along with the structure. Where is the structure? The structure is that a list exists, a set of items, and these items are homogeneous. For example, each ingredient item is a piece of something that you need to prepare your meal, and each step of the preparation is an action that you have to do in a precise order to obtain the meal. From a more low level point of view, UL is the element that you have to use for unordered list, and OL, that of course stands for ordered list, is the other element for ordered list. And finally, LI, list item, is the element you have to use for each item. Note the specification, for example, says that the element list item should only be included inside a OL element or a UL element. Okay? So this is a syntax specification that is included within the big manual. Okay. BR, just as for a break line, is what you should use when you want a line break. Again, what does the specification mean with the author wants a line break? Line break from the point of view of the information nature itself, not from the point of view of the representation. For example, in a poem, in a piece of poetry, a line break is part of the information, because the author of the poetry wanted to put probably an emphasis or a structure to his artistical expression by putting a line break after a given word, maybe because he wanted to give a given also structure in the reading of the piece of text. Another case in which the line break is part of the information and not of the representation is in addresses. Typically, addresses are composed by many lines. For example, the first line is the name of the person or organization. The second line is the location in terms of street or building or something similar. Then there is the city. Then there is the state, and so on. The addresses are organized in lines. So break line, line break is part of the information. It's not part of the presentation. Okay. Again, the specification. If you click here, you have you go to the source of the specification, where there is the full description of all cases when to use break line. You can include images in your document. You can do this by using the IMG element, which stands for image, and specifying the src attribute, which should specify should be whose value should be equal to the location of the image file. Usually, the location can be expressed as the similarly to the href value for the anchor element, and should locate just the image resource that you want to include in your document. There is also a popular discussion about an important attribute of this element, which is alt, which stands for alternative or fallback content. There is a long discussion about when to use and what to set to this attribute. This attribute value should simply include the content that the user agent, or in other terms the web browser, should show when the image is not available. And it should show this content in a way that the full information contained in the document remain the same. So if a document contains an image and the image is there just for decorative purpose, probably is not needed to include any fallback content. But if the image shows something that is needed to fully understand, fully consume the document, the web document, so a fallback description should be provided. For example, if you are making a document, let's say, where is my business, and the image is a map of where the business is, and there is only that way for the user to see where the business is, you should provide a textual description in the alt attribute, because in case where the image is not available, cannot be shown, cannot be rendered by the web browser, for example, because the web browser is a web browser for blind people, there should be a way to give the same information without using the image, and the same information can be given by in terms of a textual description of the map itself. Finally, there is a way of specifying tables. What are tables? Tables are a structure, information structure that embed pieces of information that are homogeneous and organized usually in two ways, in columns and in rows. Typically, rows are a way of specifying different attributes of the same instance of information, and typically columns are ways of specifying different attributes for different items for the same different items, different instances from another point of view. For example, if you consider a piece of the telephone book, from the paper version of the telephone book, each line probably has a name, first name, last name, telephone number, and the address. Here the instance of the information is the content information. The attributes of the information are these four things: first name, last name, telephone number, and address. The table is a good way to organize the information because you have one row for each contact and one column for the first name, one column for the last name, and so on. Again, this is not a matter of representation, it is a matter of nature of the information itself. This kind of information is suitable from another point of view. The table is suitable for this kind of information. So, the table should be used only when the information deserves a table. Before going on this consideration, just a mention about elements that are actually used to describe tables. Tables is described by the element table, which contains at least the element t-body, which stands for table body, and the table body contains rows organized by element tr, which stands for table row, and cells, the minimal instance of data information in a table. You can also provide heading and footer for a table by means of elements the head and the footer, and you can also provide a caption, which is a short textual description of the table data. Okay, let's return on a discussion about the table and its use for representation. This is an extract of the specification that say in practice, do not use tables for representation, do not use tables for layout. They say historically tables have been used for specifying the layout, the desired representation of the page. This is the layout. But this is wrong. Okay, they also say that first there are other means for specifying layout. We are going to see just a small part of this means. And second, simply you should not do this. So if you use a table for specifying layout, then your document is non-conforming. Your document is not good from the specification point of view. Okay, let's start the last part of our lesson, and I think we can do the second break, not too long, please, because we have some other content. So 5-10 minutes. Okay. So the transformation of that document in a tree is quite simple. The fact that the tree lives in the memory is irrelevant for us. So this document becomes this tree. It's quite simple. You can see the doc type. Consider that there is a root, an abstract root of the tree. Then this root usually has two children. One is two branches in terms of tree. One is the syntax specification, the doc type, and the other is the HTML element of, using the terminology of trees, the HTML node. Then the HTML node has two children nodes. One is the head node and the other is the body node, and so on. The tree structure is quite easy to obtain just looking at this piece of text that is the HTML document. We can draw with a pen and a piece of paper the tree structure of the HTML document. So the first transformation is quite easy. I think you understood it. Is quite easy to make by hand, and it's quite easy to write a program that makes this transformation. Of course, if this document is not valid from the syntax point of view, for example, because there are two overlapped elements, it's not possible to transform this piece of text in the corresponding tree, because two elements that are overlapped cannot be transformed in a portion, in a subtree, in a portion of a tree. Okay, so the first part is quite easy. Just see some terminology. For ease of representation, I show here just a piece of the tree of the previous document, the piece of the tree corresponding to the body subtree. Okay, what is a subtree? Is just a portion of the tree that starts from a node and goes at the leaves of the part of the tree. So the node body in this case is the parent. In body you can see the terminology is the parent of node H1. The nodes P, comment, and sibling are the node P and comment are sibling of the node H1. The node H1, P are children of body. So each of H1, P, and comment have a single parent, but that parent, which is body, have 3 children, and each of the children has 2 siblings. Then note A, H1, P, note the A that is the difference between the second line of the list, are descendant of the node body. Descendant are the children, and the children of children, and so on. And finally, there is a distinction between types of nodes. There exists a type known as DOM element, which correspond to HTML element, and there exists a type known as text nodes that correspond to pieces of text that usually are that are textual content or of other elements. Note that a DOM element can indeed have a child or more children, while text element cannot have any children. Okay, once we have this representation in the form of a tree that lives in the memory of the program, how can we transform the representation in a drawing on the screen? And this is the most difficult part. Note that it's not just a matter of drawing on the screen. This is just one of the cases, and it is the most common case. But other cases are those concerning the representation of the information for blind people, for example, and this could involve speaking the document, speaking the information, or representing the information on a particular device called the braille screen, which does not have colors, but is formed by small pieces coming out from a playing device. But we could also imagine other kind of representation, for example, representation of a big screen, or representation of a small screen, and so on. In general, however, the most common representation, and the one we are talking about, is the representation on the screen. So, you have that structure, the one we saw before, that is the DOM tree. How to transform a given DOM tree in a drawing on the screen from the developer point of view, the developer of the web browser. Yeah, that is the developer of the web of the computer program that takes care to make this transformation. How to write down the programs that in general transform every possible DOM tree in the corresponding and correct representation. Okay, to respond to this question, we see something in the next slide, but again, the full response is on the specification, because the specification is also useful for developer of web browser. Okay, in the specification, it's written how to transform, for example, an element P on the screen. It's written. The main information is when to use an element P, but the other, and this is part of the information is useful for the web author, but the other part is how to represent an element P. Okay, however, let's see just a sketch of this transformation, which is indeed quite complex, and we are not going to see all the details. Again, recall that we are going to transform a DOM tree in a representation on the screen. A representation on the screen can be viewed is indeed a set of boxes. Each box is a rectangular portion of the screen, a rectangular region of the screen, and these boxes are themselves organized as a tree. So the transformation can be reconducted to a transformation from a DOM tree to a boxes tree. Okay? There are two main rules for the transformation. The first one says that each DOM element may generate 1, 0 or more boxes. Okay? So there are all cases. One DOM element could generate 0 boxes, 1 box or more boxes. One simple case in which one element generates no boxes is, for example, for the head element. The head element is not represented graphically on the screen. In that case, the element does not generate any box. Okay? The other cases are quite. In the case of 1 box is the classic case, and the other cases are quite more complex. We are not going to talk about them. The other rule concerns the hierarchy of boxes. In other way, the structure of the boxes tree. In practice, the rule says that one box BE corresponding to one element E where BE is a node in the box tree and E is a node in the DOM tree, maybe the child, two cases, maybe the child, one of another box B prime E corresponding to E, or child of another boxes B second E prime, where E prime is a child of E. In practice, this says that if an element E is a child of another element, let's see, F in the DOM tree, this kind of relationship cannot be subverted too much in the boxes tree. That is the box corresponding to E cannot be the parent of the boxes corresponding to F. In practice, this says that the shapes of the two tree are quite similar, not identical, but quite similar. Okay, then one first question is which elements of the DOM tree should I browser should I draw? In other way, which element should I transform in boxes? Because I said that one element could correspond to 0 or more boxes. The rule is quite simple. You have to you have to transform one element in a box if and only if its parent has been drawn, or there is not a specific instruction to not transform the element. So, in first approximation, each element should become each DOM element should become a box element. But if you specify in a way that we'll see later not to draw something, then you will not transform that element, and not neither its children. Okay. Another fundamental question is where to draw. We in some way obtained this tree of boxes. We have to place the boxes on the screen. The screen is a rectangular region. The tree is just an abstract concept of representing things. We have to transform the boxes tree, where each box corresponds to a region that should be drawn, but we have to decide where to draw these regions. The actual set of rules is very complex. I just give you a sketch, really easy approximation. Okay, let's start. There exist three kinds of blocks. The first one is known as block level box, the second line box, and the third inline level box. If you, for help you, imagine a page of a book and consider three kinds of pieces of text: the paragraph, the line, and the word inside the line. Okay, so you can reconduct the three kinds of boxes to these kinds of concepts on a printed page. How to place boxes? Well, it's quite easy if you consider the parallel I told you before, because two block level boxes as two paragraphs as simply to be drawn one below the other. You take the screen, which corresponds to a rectangular region. You have to place these two boxes. You place the first box, two boxes that are block level boxes. The first one you put it on the first available part of the region, then you put the second one below, just two paragraphs. Lines, it's quite the same, because two lines should be drawn consecutive, one below the other, inside the parent block level box. And finally, the inline level boxes are drawn like words. So one aside the other until the end of the line, and then we start again with another line. What do I mean with consecutives? Consecutive in the structure of the DOM tree. Okay, the DOM tree is obtained by reading HTML, which has an order, which is sorted in a way. ordered like the author decided to order it, and this means that the DOM tree is also ordered, and you have to follow, the browser, have to follow this order while placing boxes. Okay, this is just a picture to understand the process of transforming or placing the boxes on the screen. We see the code on the left, the source of the HTML document. We skip the second transformation, that is the DOM tree, but we just consider this piece of HTML and try to place on the screen. Consider that the screen is given by the dotted region on the right. You should the content of the first P element is transformed in a box, and this box is placed occupying the full screen at the top. Then the second paragraph is just put below the first box. Inside the first box there is a set of lines, and each box, for example the EM, the box corresponding to EM element, is put in the line, split in this case because it's composed by two words and the line is ended, following the order that you expect to follow in a line of text. Okay, but this is just a sketch of the procedure, and moreover we miss some important details. For example, given an element, I say that there are three kinds of blocks. Given an element or an element type, what box should I use for that element? Or given a box type, should I leave some margin? For example, I say one box below the other. Should I leave some margin while drawing the two boxes? More in general, these questions are about how to draw these boxes. The responses are known as style properties. For example, one style property is the margin. Given a box, its style property known as margin says which margin should I leave around this box. Another property is the box type. Given a box, which should be its type, should be a paragraph that is block level box or an inline level box, and so on. There are all the properties concerning the colors. Should I draw the background of this box in using a given color? Should I use a given color for the text, and so on? All these respect of the drawing procedure are known as style properties. And how to specify style properties? Using CSS, that are cascading style sheets. Cascading style sheets, CSS, is just a syntax to write documents that give values for the style properties. Okay? Quindi, so in a CSS document, an author specifies which style properties he would like to apply to the representation of his document. What kind of information is given by a CSS? For example, from an informal point of view, the information should be something like each P element should be drawn with a block level box with a margin of 1 centimeter, black text color, light gray background color. This is a kind of information that we expect to find in a CSS document. Who writes down a CSS document? Usually a CSS document is written by the same author of the corresponding HTML document. In the HTML document, the author specifies the information and its content. Then he wishes that information is represented in a given way. Then he produces a CSS document. In some way, he connects, links the two documents. We will see in which way. And then he also obtains the desired representation by specifying a CSS document, which is a companion, a sort of companion of the HTML document, which as I said before, contains only the content and information itself, the content and structure of information itself. Okay, but probably you know that in many cases you can produce an HTML document and you can appreciate a representation of this document also without specifying a CSS document. So, in this case, the browser produces a representation of the document without having the values for the style properties that allows the browser to produce the transformation between the box tree and the screen representation. How can the browser produce the representation? Simply using a set of implicit rules, a kind of standard CSS document which contains a set of standard rules. This set of standard this set of standard parameters for the representation, that is the set of standard values for the style properties, is contained in the HTML specification as usual. So here, if you click here, you can see the piece of text I reported here that says where otherwise specified the user use the user agent level style sheet, and then in the specification follows a long list of default values for the style properties, which allows a browser to produce a representation of a given box tree, of any box tree. Okay, let's see the syntax of a CSS document. A CSS document is simply an ordered list of rules. The order in this case matters. Each rule is simply composed by a selector and 0 or more declaration. A selector is something that allows the browser to understand to which elements should the following declaration apply. The declaration is just something that say what properties values apply to what style properties. Finally, in fact, the declaration is just composed of a property name and a property value. So, for example, in the informal example I told you before, the rules was composed by only one rule. The rule have a selector, and the selector is each p element. Okay. Then follows four declarations. The first declaration concerns the block type, and so that the property name is the block is a name that we don't mention here, but is concerns the block type, and the value is block level box. The second is margin, and the value is 1 centimeter. The third is color, text color, and the value is black, and so on. This is informally. Formally, this is the syntax of a CSS document. Again, a CSS document is just a piece of text, but the structure of this document follows what I said to you before. This is a list of rules. You can see the first rule from line 1 to line 5. There is a selector followed by parentheses. The content of the parentheses is the list of declarations, and each declaration is contained in one line. This is not compelling, it's just a style question, a style decision, to design choice to put one declaration for line. And in this declaration, in this example, line 2, you can see a declaration, property name, comma, colon, property value. You can see at the last line there is also a way to specify comment in the CSS document. Again, comments are not useful for the purpose of setting style property values, just a comment usually for the author of the CSS document himself. Just a brief history. CSS was born in 1996, The last version, the one that we are talking about today, and which is a companion for the HTML5, is began to come around in 2005. It's also CSS3, like HTML5, is under development, but is widely accepted. At least the largest part of the specification is widely accepted. Note that the specification about CSS syntax and meaning is contained in the HTML specification. From another point of view, HTML is both the name of the language and the name of the specification itself. The specification itself also contains information about style sheets. And both are in the section of web design and application standards of the consortium, www consortium. Okay, how I said that a CSS is usually produced by the same author of the web document. How can the author make the two documents work together? Usually, here are three ways of performing this task. The first one is specifying that a given CSS document should be used for setting style properties when representing a given web document, and this can be done using the link element inside the HTML document. The link element has one attribute, href, whose value is the location of the CSS document. Another way is using the, again, inside the HTML document, using the content of a style attribute, the style element. The content of the style element is should be just a sequence of characters representing a valid CSS syntax. Finally, there is a different third way that allows the authors to only specify declaration just as a companion of a given element that he wants the properties applied to. And this is accomplished by using the value of the style attribute. Not style attribute and style element are two different ways of attaching style properties to our document. Okay, so let's talk about the CSS selector. What is a CSS selector? It's the first part of a CSS rule, and is the part that allows the browser to understand to which element the given rule applies to. From another point of view, the selector can be viewed as an expression defining a function which returns a boolean given an element. That is, a function which receives a single argument, which is an element in a DOM tree, and returns a boolean value corresponding to yes, apply the declarations to this element, or false, do not apply the declaration, do not apply the style properties. In the specification, there is the syntax, the set of possible syntaxes for the selectors. And so, in other words, there is all the possible universe for this valid function corresponding to selectors. Okay, let's see the base selector. The base selector is includes these possibilities. The first one is the asterisk, the white char, that corresponds to a function that always returns true. That is, if you write the selector, the first ballet, you are saying that what follows in the rule applies to each element of your of any DOM tree. A selector given by including just the name of an element is the selector that returns true only for that kind of elements. For example, the selector A just returns true for all anchor elements and false for all the other elements. Then there is the descendant selector AB, which means that the function will return true for all and only the elements of kind B that are children of element of kind A. Then there is the selector concerning the ID attribute that we did not explicitly see. It's just an attribute that can be specified for any element type. And then there is the selector for the class name. What is the class name? Is a kind of attribute quite important. We are talking about HTML because we are talking about attributes. Is an attribute whose name is class, and whose values is a space, is a list of values separated by spaces. Each value is a sequence of letters or numbers, not the first character cannot be a number, which is a class name. When you specify, for example, image, class, photo, space, old, you are saying that that element is of class photo and of class old. That is another way that emg dot photo and emg dot old will return true for that element. Okay, there is also the possibility of combining selectors, combining base selector. For example, in the first line you can see a.c1 space b just selects all b which are children of an A element of class C1. ABC just returns true for elements of kind C that are children of descendant of element of kind B that are descendant of element of kind A. A space asterisk return true for any descendant of A. The white asterisk is also known as the universal selector and can be omitted in the syntax in many cases. For example, when it's followed by specification of the class or of the attribute. There is also a set of selectors syntaxes concerning the relationships between kind of nodes. For example, a closed angular bracket b selects all the children of kind b, all the children of a of kind b, which is different from just a space b with which returns all true for all descendant b of element a. A plus b selects the b which are immediate sibling of a, and a dot symbol b returns selects all b that are just sibling of a. I remember sibling is two nodes are sibling if they share the same parent. There is a wide choice for specifying selector that acts on attributes values, and all these ways involve the using of a square bracket. E square bracket A selects all nodes of type E with attribute A set, just set. It does not pose any requirements on the value of attribute A. Then there is a long list. We are not going to read all the possibilities, but you can select acting on the value, on the suffix or prefix of the value, on a list of on attributes that are supposed to include a list of values separated by spaces, and so on. There is an interesting kind of selector that acts on what is called pseudo-classes. A pseudo-class is just a class that is not explicitly defined and specified in the document. For example, the most interesting pseudo-class is the one concerning the order number of an element among its siblings. This selector has the syntax column and child parentheses n, where n can be an expression, for example, just a number, for example, let's say 4. Then the selector will select the fourth child of kind E among its siblings. This is a common way to, for example, give a different background color to odd and even rows within a table, which usually make the table more readable for the final user. And yeah, indeed, this effect can be obtained using this expression, this syntax, and child 2n, which selects even children, or and child 2n plus 1, which select odd children. Again, I remind you to the specification for full details about each selector type. There exists also a concept known as pseudo-element. Pseudo-element, differently from pseudo-class, but in another way, is an element which is not explicitly defined, but is fictional. What is a fictional element? For example, in a simple line of text, the first word is a fictional element. It's not explicitly defined. There is not an element whose content is just the first word, but the first word, okay, first letter, but there exists a fictional element whose content is indeed the first letter. You can select that fictional element by using the pseudo element selector colon first letter. In the same way, you can select the first line, or you can select two fictional elements that precede and succeed each element, and these two elements can be selected using before and after pseudo element selectors. This is an example. Consider a piece of text. There is a line of text. Above you can see the HTML code, which we can also consider like a representation of that particular piece of the DOM element. If we select an element, if we produce a selector P colon first letter, it's like we were selecting the HTML element in red in the above part of the slide. Note that that element is fictional. The author did not include that element around n in the piece of text. It's just an element that is generated for the purpose of representation if there is a selector that selects that element. There is also selection for negation that allows you to select all things but things that match a given selector, and the syntax is just by using a colon not and between parentheses the selector that you want to negate. Okay. With selector, you specify for the user of the browser to which element apply declaration, that is, to which element apply given values for given style properties. So let's see just a couple of style properties and corresponding values just to understand what we are talking about. The full list again is available on the specification, and also on the website that is a bit more easy to consume of the W3 schools. Okay, there is a set of properties, style properties concerning colors. The main three are color, which is just the foreground color, background color, and border color, which, like the name suggests, are to specify color, foreground color, background, and border. When you give a value for a color property, you can use the color name, including exotic name, I mean name that you usually maids don't know, and or you can use hexadecimal values, like using RGB channels, or decimal values, percentile values, or also you can use the alpha channel, which is a channel for specifying transparency of the color. You can also use images as background. Again, the details are available online. Note that you can specify many respects of using images as background. You can specify not only the location of the image you want to use, but you can also specify if the image should be stretched and enlarged to cover all the box, or eventually reduced in size. If repeated, where should be the image be attached at the center of the box if smaller, at the center, upper left corner, and so on. You can also specify all these things using one single style properties, background, which is just a shorthand for all these properties. In the same way, you can specify values concerning fonts, the font family, which is the type of font, size, weight, thin or thick, variant, style, and so on. There is in the last version of the CSS specification a handy way to use fonts that are not available to the platform of the browser which is rendering the document. This can be done using the at rule, which is a special syntax construct consisting of an at character, font face, colon, and data structure including the location of the font. The details are quite more complex, but consider that you can use a very large set of fonts. This mechanism is also known as web font. For example, Google is itself a provider of web font and allows you to use fonts that Google itself provides. So you can be sure that everyone who is able to access the Google server, which is almost anyone, should have that font that you choose available for rendering the page. An interesting thing is how to specify sizes. There is a large amount of ways to specify measures within a CSS, not only concerning the size of the font, but also for everything that concerns the measure of something. For example, the dimension of boxes. You can use absolute measures, inches, centimeters, millimeters, and so on. Or you can use relative measures, for example, a measure that compares to the size of the font, the base font, or measures that compares to the size of the viewing device, in other words, the screen, or percentile, and so on. There is a wide choice. There is a large amount, of course, of properties concerning text, line height, letter spacing, and so on. One very important property is the display property that responds to one of the main questions we had at the beginning, that is which kind of box should I use when transforming a DOM element in a box tree element. This can be decided using the display property. Display property can have many values, many different values. The three one that we considered before, among the three one, the first one, inline, correspond to inline level box, and block correspond to block level box. When we specify none, we are saying the browser that all the elements to which this declaration applies, that are all the elements selected by the corresponding selector, should be not transformed in a box tree. In other way, you are not representing these boxes. For this reason, this property easily affected the rendering of a given document, because you can simply hide, not draw a class or a set of elements. The size of boxes for not all kind of boxes, but in first approximation just for block level boxes can be specified using size properties whose names are width and height easily. You can also hide the box using the visibility property. Visibility and display are not the same thing. With display, you are saying that you don't want the browser to transform a given element to a corresponding box with display norm. With visibility hidden, you are saying, okay, transform that to a box, but do not draw it. Which is the difference? The difference is that while positioning other boxes, you are considering a box that is actually hidden, but indeed influences the way you are positioning the other boxes. Okay, again I say the full list of properties, values and so on, selectors, is available on the specification. It's not very interesting to go too much in details in the specification, because it's probably necessary to have some practice, so here we cannot have practice. But this was just to give you a high level point of view on how the process of producing information from the author and through consuming from the point of view of the user consumer using a web browser which represents the information is carried out. Okay, this is the end of the lesson. If you have a question, I'm here. Okay, thank you.